Now web for Pentester course, SQL injections. SQL injection are one of the most common web vulnerabilities. All SQL injections exercises found here use MySQL for backend. SQL injections come from a lack of encoding escaping of user control input when included in SQL queries. Depending on how the information gets added in the query, you will need different things to break the syntax. There are different ways to echo information in an USQL statement, using quotes, single quotes or double quotes, using backticks, and directly. So now let's do the examples. Example number 1. In this first example, we can see that the parameter is a string, and we can see only one line in the table. To understand the server-side code, we need to start poking around. In this, let's click on example number 1 in the server, and now let's add a simple code at the end to escape, an OR, and a 1 checking to see if it is true. So it will bring everything that is in the query if the name equals root, or if it finds that 1 equals 1, which is true. We want to add the last single quote because it will escape it again, and we do not want that. As you can see, doing this, it broke all the registers in the database: admin, root, user 1, and user 2. Now let's move on to the next example, example number 2. In this example, the error message gives away the protection created by the developer, error no space. These error messages appear as soon as a space is injected inside the request. That means that we cannot use a space in our query, but we still can use tabulations to simulate those spaces, or comments, for example. So let's try it with the tabulations. In this case, the correct encoding for the URL for a \t, which stands for the tabulation, is %09. That's or another tabulation, and check if 1 equals 1. As you can see, again, all the registers in the database. Let's move on. Example number 3. In this example, the developer blocks spaces and tabulations. There is a way to bypass this filter. You can use comments between the keywords to build a value request without any space or tabulation. So let's now try it, but instead of spaces or tabulations, with comments. And as you can see, again, we get the expected output. In the example number 4, this example represents a typical misunderstanding of how to protect against SQL injection. If the 3 previous examples using the function MySQL real escape string will have prevented the vulnerability, in this example the developer used the same logic. However, the value used is an integer and it is not echoed between single quotes. In this case, we can use the quotes, because that means that we would get an error because he's expecting an int instead of a string, but we can use again spaces. As you can see, the expected output. Let's move on to example number 5. This example is really similar to the previous one, detection-wise. If you look into the code, you will see that the developer tried to prevent a SQL injection by using a regular expression, which says error integer required. However, the regular expression used is incorrect. It only ensures that the parameter ID starts with a digit. The detection method used previously can be used to detect this vulnerability. So he's only checking to see if ID is still if the input of the first digit of the first parameter is an int, and as you can see, ID equals 2. It is an int. We can basically do the same injection as last example, and it will work. Example number 6. This example is the other way around. The developer made a mistake in the regular expression again, but it ensures that primary ID ends with a digit. It does not ensure that the beginning of the parameter is valid. You can use the methods learned previously. You just need to add an integer at the end of your payload. So basically, we just need to have an integer at the end of our payload, and the injection that we use in the last two examples works as well. There you go. Example number 7. In example number 7, another bad regular expression. Here we can see the beginning with a upper arrow and the end with a sign of $. Of the string are correctly checked. However, the regular expression contains a modifier PCR multiline. The multiline modifier will only validate that one of the lines is containing an integer, and the following values will therefore be valid. So we can use a multiline injection, but to simulate this, we can use the correct encoding for the \n. In this case, the correct encoding for the \n is percentage 20. I'm sorry, is percentage 0A is the correct encoding, so we can use it to perform our SQL injection. So ID equals 2. We will say percentage 0A or 1 equals 1, and we get the expected output. Example number 8. Example number 8 is a little bit different. The parameter name gives away that there will be echoed in the SQL query. If you look into my SQL documentation, there are two ways to provide a value inside an order by statement. Directly order by name, which we can use, and between backticks. The order by statement cannot be used with value inside a single quote or double quote. So in this case, we have to use the backticks, and it will look something like this. The output is basically the same, but here we are using the order by name that it's indicated in the example. Example number 9. The example number 9, similar to the previous one, but instead of a backtick, there are other methods that can be used in this case. Since we're directly injecting in the request without a tick before, we can use the MySQL if statement to generate more payloads. And if we use if one name age should give the same results, and if zero name age should give different results. The difference with one another is which order it applies, by name or by age. You can see this is the same output, and with the other one, let's change this by 0. The output is different, is ordered by different.